which is an overview of the Transit Analytics Lab. So I'm going to unshare my screen. I'm going to okay. Okay, so the Transit Analytics Lab was created earlier this year through an internal fund by the Faculty of Applied Science and Engineering at the University of Toronto, and already it actually extends previous research and development activity at the University of Toronto in the area of transit data analytics. So it's no secret that transit, there's a number of trends that are disrupting the transit industry, including automation and connectivity. So there's more and more promise really of connected vehicles and automated technologies to be integrated with public transit services and operations for the improvement of the attractiveness and efficiency of transit systems. Also, electrification of transit fleets is also another big trend disrupting transit systems. Shared mobility is also clearly a threat, an opportunity at the same time to really integrate public transit with ride sharing and other shared mobility services. So this is again another really big development that is really impacting public transit, as well as big data. So public transit agencies are increasingly, and this has been really a growing trend over the past decade or so, that there is transit agencies are data rich as they increasingly equip their transit fleets with more intelligent ITS systems and automated passenger counting, vehicle monitoring, and fare payment. Also, at the same time, we see new sources of data that are emerging, such as social media is one source of information where people tweet about public transit, their user experiences, and so on and so forth. Also, smartphone apps are producing data that are relevant to transit operations. Sensors like Wi-Fi, Bluetooth, and accelerometers are also producing streams of data that are potentially very beneficial for transit planning and operations. And all these data sources and data streams are over and above really what we have traditionally in terms of origin destination travel surveys, ridership satisfaction surveys, passenger count surveys, and so on and so forth. So as you can see from this picture, transit agencies, and I'm sure you can tell us more about that, are swimming in transit data. So to harness this data and turn it into insights, there's clearly an intermediate step that is required to process this data and visualize this data and analyze this data. So there's a set of tools that is required for storing, visualizing, and analyzing this data. And and this is really the crux, really, or the main focus of the Transit Data Analytics Lab, is really to work in this bottom box specifically on tools that really help with visualization, help with decision-making tools, and so on and so forth. So as I mentioned, Transit Analytics Lab was launched a few months ago, specifically in May of 2020, to bring together both transit and technology researchers from across the university. Because it's not us in the Department of Civil and Mineral Engineering that work on public transit, but there's a wide variety of researchers across the university that also do very interesting work on public transit and data analytics as applied to public transit. But also TAL is intended not only to bring researchers together, but also to bring as well transit system professionals and from the golden horseshoe and the private sector software providers, all really to bring them in a common forum for promoting and advancing data-driven decision-making, with obviously the objective of delivering improvements to both user experience and system efficiency. So more specifically, TAL really aims for, or will try to foster innovation in transit data driven tools using advanced methods of data science, machine learning, AI, simulation, and statistics. Also, TAL will aim to facilitate training of U of T students. We want to train the next generation of transit professionals with advanced tools such that they can process and make sense of the data that they will be working with when they work for transit agencies or in the private sector. Another very important really objective of TAL is really to expose the professional community to advanced analytics through knowledge transfer activities. And I'm going to talk a little bit more about this later on. And finally, we're also hoping to really work with others to develop standards and integration methods to accelerate the advancement of transit analytics. So those are the major objectives of TAL. We're trying to be as broad as possible in our scope. So we traditionally have been working with fixed route transit, rail and bus modes, but also we're working with demand responsive transit and how that could be integrated with fixed route networks. With respect to the decision-making domain, we try to cover really the full range of service planning, scheduling, real-time management, customer experience, corporate management, and maintenance. And we, like many others, we like really to think of classifying the analytics that we work with in terms of descriptive analytics, predictive, and prescriptive slash optimization. So I'm going to walk you very quickly in a few minutes about some of the ongoing and recent projects on transit data analytics. And this is by no means really a comprehensive coverage of what we do or what other researchers at U of T also do. So the first project, which actually the first two projects, you will hear more details about them. There's the TAL research session later on will feature those two presentations. But very quickly, the first project is on developing really visualization and processing analytics on open transit data for really deriving or developing metrics for reliability, access, and equity. And the focus really is on US mega regions. It's a project in collaboration with other academics from the US. Social media analytics for transit planning and management. This is also developing analytics to process and visualize social media, specifically tweets about public transit, and really harness this information for transit planning and management applications. In terms of predictive analytics research, we've been working for a long time on prediction models or predictive analytics for bus travel time, as well as bunching incidents. We're trying to develop tools that predict really the occurrence of bunching incidents in real time. And we developed a reliability framework that really recognizes the conditions really in which public transit is operating and really selecting appropriate analytics for a different reliability region. And by reliability, we look at not only service reliability, but also data quality. Ridership forecasting and elasticity analysis, it's been a major area of activity. My colleagues, Professor Eric Miller and Kanker Habib, have been very active in this area, and we've done some work on forecasting, doing long-range forecasting of ridership across Canada in a recent study for CUTA. We've been very active in the area of transit disruption management, and developing tools to help transit agencies with devising really effective response. So one tool we developed is so-called Dash Bus, which is a tool really to help transit agencies with delivering effective bus bridging strategies. So the picture you see on the right is really a visualization of two possible bus bridging plans. One in which, the left one, you draw a lot of buses from from locations that are very close to the disrupted subway segment, whereas the other one shows a different plan where you draw buses from across the network. Data-driven tools for prediction of driver absenteeism and multi-depot bus scheduling. This is a new collaborative project with one of our private sector companies in Toronto. Again, trying to really utilize the data. All those tools that I'm talking about really are very data heavy, they are data driven. So in this particular application, we're trying to develop tools that would predict driver absenteeism in both the short term as well as the long term. Long term here, we're talking about, next 3 months or so. Short term we're trying to develop tools to predict, driver absenteeism tomorrow or, next week. And also linking this to multi-depot bus scheduling, especially in the context of hybrid fleets where you have diesel engine buses as well as battery electric buses. Transfer optimization, transfer time optimization, and real-time connection protection. Again, utilizing the wealth of data and information to really improve our scheduling practices such that we minimize transfer delays, especially in a city like ours here in Toronto, where there's a very high percentage of transit trips that really involve one or more transfers. So really coordinating the timetable such that we minimize the transfer time is very important, and while still recognizing really the stochastic behavior of our transit systems. This is at the planning stage, but also in real time, we're aiming to develop really strategies that also try to protect any planned connection in the timetable. So via holding strategies or expressing strategies. I mentioned DRT before. It's been a growing area of activity in TAL. One specific project we're working on right now is to develop a decision support toolkit for planning integrated DRT and FRT fixed route transit networks. So the tools that we have right now are either focused on fixed route transit or demand responsive transit, but not really the integration of both. So we're trying to develop some software systems, again, utilizing the rich data that we have to enable transit agencies to plan such networks that are sort of hybrid fixed route transit and demand responsive transit, and is able to represent such scenarios and analyze them appropriately. In terms of also prescriptive analytics research, now recognizing that in the very, very near future, we will see really the deployment of connected vehicle technologies into bus systems and bus routes, and we can utilize and leverage such technologies by really coming up with new advanced strategies for connected bus routes. So we have a very ambitious project involving multiple students that are looking into really utilizing such technologies to, for example, implement coordinated TSP along a corridor such that we ensure headway regularity, so we can speed up a bus but delay another bus such that we regulate the headways. Dynamic bus lanes is also an interesting concept. Some jurisdictions are considering it, as well as bus platooning. We've recently, a few days ago, we read about TTC considering bus platooning. So those are also some advanced strategies that we are looking into developing really the tools to enable transit agencies to analyze such strategies and optimize them for any given context. Last but not least is another ambitious project that really is focused on multimodal transit hubs, like Union Station, but also the connecting network, the subway network, the commuter rail network, as well as the connecting streetcar and bus routes that are focused on those hubs. There's obviously, those are very complex, really, portions of our transit network that really require special attention. There has been some advancement in research and some methods that have been applied to traffic networks, and we're trying to really explore the application of those methods in the context of multimodal hubs. So that really involves micro simulation and macroscopic flow diagrams and so on. And our context here really is our Union Station and the connecting network in Toronto. So this is really a very, very quick overview of some of the projects we're working on. TAL is not really working alone, is working with researchers from other centers as well within U3 and outside U3. So TAL collaborates with CATS, which is the Center of Automated and Transformative Transportation Systems, which is one unit within U3. DMG, TMG, many of you are familiar with those. CART is a center in the Faculty of Engineering at U of T that is focused on AI and machine learning. School of Cities, SASI Lab, my colleague Steve Farber heads this lab, and we work very closely with each other, as well as other centers within U of T and even outside U of T. So over the past few years, but more so in the last year or so, we've been working very closely with many partners from the public sector, the private sector. Also, we've been funded by research agencies, both federally and provincially, as well as nonprofit organizations. This is the core team of TAL, myself, Professor Eric Miller, Habib El-Darabi, and others from Faculty of Engineering, and also Professor Steve Farber from Geography, as well as I mentioned, we collaborate with others. They are not shown here, but this is the core team. We have a large student body, and as well as postdocs and research associates. So at the current time, we have about 15 people working on those different projects that I outlined to you. Future plans, we're actually aiming to become a world leader, or among the world leaders in research and development in the space of transit data analytics. And this is obviously, we cannot do this alone. We work in partnership with the industry, both the public sector and the private sector. Our future plan also includes really enhancing the curriculum at U of T, especially at the graduate level, with more courses that are focused on transit data analytics. And some versions of those courses will also be offered for professional development courses. And this is not really, I'm not talking about the distant future. This is really aimed for year 2021. We are currently developing the curriculum for a transit analytics course to be offered next year. Also another plan, as I said, we are hoping really that we become a forum for people from the industry and academia to come together and share their experiences, share their frustrations, their priorities and needs, and really identify ways of working together. So we intend really to have a regular program of workshops and even international symposia and conferences that are focused specifically on transit data analytics. With this, I hope I've given you a quick overview of TAL, what it does, what it aims for, and what its future plans are. If you have any questions, very quick questions now, I'll be happy to answer them. If not, I'll ask my co-organizer of this workshop, Dr. Brendan Hemley, who's also a senior advisor to TAL, to give you a recap of the Transit Data Symposium, and also, how it actually, how we got to this point, what the evolution of work in this space over the past decade or so. So I'll stop sharing, and Brandon.
I think we've got one question.
Oh, okay. Is that
You're still muted, Jim, it looks like.
Yeah, that's Jim. Jim, you're muted.
Looks like it's, you can ask it later or just type it into the chat and we'll get to it. Same goes with everybody. Feel free to use the chat for questions. Oh, there we go. Now we can hear you.
Oh, I'm on. Okay. With this multidisciplinary effort with TAL, do you have any, could you share anything more around working with industry partners and with public sector transit? One thought I have is that with individuals who are working, it's very difficult to get the capacity to sort of take time out to understand what the latest thinking is and critically how to apply that in day-to-day jobs. So you end up with this sort of separation and it's hard to get together. Do you have any thoughts around that?
Well, yeah, we have a lot of thoughts about that. So far, we've been working really with industry partners, including the public sector, transit agencies, on a project-by-project basis. It's either we bring an idea forward and we discuss it with the transit agency, or vice versa. The transit agency comes to us with some research needs that we conceive a project together. We work on it collaboratively. It's been very fruitful and productive, but it doesn't really provide a long-term vision for both really the transit agency and TAL to work collaboratively on a stream of activities, research activities that would be of mutual benefit to both parties. So that's something we're hoping that TAL will slowly but surely, that we can come up with some sort of a model by which we can work on a stream of projects that are really serve the needs of the transit industry, but also help advance our research agenda as well. Okay, yeah, and we'll touch upon those points throughout the workshop later today. So over to you, Brendan.
Okay. There we go. Oops. I think things are a little slow with everybody on. It's all right. Okay. There we go. Okay. Well, greetings. My name is Brendan Hemley. I'm an independent consultant. Amber was kind enough to say that everybody knows me, but I don't think that's quite true. So just a bit of background. I've been involved in the transit industry for a long time. I worked 15 years at CUDA as manager of research and technical services, and I've been an independent consultant for 20 years, working both Canada and the US. My whole focus has always been bridging the gap between transit practice and the research community, and trying to encourage innovation to make transit more effective and efficient. And as a part of that, the whole issue of trying to use the data from automated systems has been a focus of mine for decades. And so I've been monitoring the situation and very happy to be a senior advisor to assist Amer and his colleagues, bringing a perspective that comes from working with both the industry and academics. as Amber mentioned, I'd like to just sort of step back and give you a perspective on what I call the transit data arc of how we got here. And then I'll focus in on recap of the Transit Data International Symposium. And then I'll go through some of the themes that have evolved through the different symposia over the years. So in terms of the transit data arc, I know many of you are young and probably don't realize this, but transit ITS actually first appeared in the 1980s in Europe and Canada a bit later. And those systems were primarily designed for addressing security, incident management, service restoration, and relied on sort of standard operating procedures. I organized for CUDA an international conference in Ottawa in 1988. And although a lot of it was on operational control, there was a session on using AVL data way back then. In 1991, we initiated and I managed a report that identified many ways that some systems were already using AVL and pass-through accounting data, APC data, for planning and management, service planning, operational control, executive management. In the mid-1990s, first AVL systems appeared in the US, again, focused on security. And it wasn't until later that even started the discussion of using the data from these systems. These systems, APCs were designed for collecting data, but AVL, fare collection systems were not. They were designed for other reasons. And in TCRP report 113 was a seminal report. It was led by a colleague of mine and I was part of the team. In 2008, there was another report on this. So the evolution's been quite slow. This shows one of the tables from the 1991 report that shows the kind of data that was already being collected for service planning purposes way back then. And I've been following the situation, and it's rather, it's been very, sorry. It's been very discouraging how slow things have been to evolve. But now we've gotten to a point where, but in recent years, there's been a lot of progress, increased focus on data. People are starting to really realize the benefit from it, to create information that can really enhance the way transit is operated and serves its customers. And a lot of discussion in the media and so forth about business intelligence, decision support systems, open data, big data, and COVID has really shown the importance of data in order to increase the agility and ability of systems to respond to the situation. And we'll be talking about that in the next session. And so what's changed? Why has it taken so long? Well, what's changed recently is that the systems have finally become more mature. There's easier access to the data. The suppliers are actually providing data reporting modules. There are lots of new visualization and analytic tools. And there's an increased discussion of the use cases of how this data can be used. This also coincides with the fact that there's a larger discussion about big data, open data, smart cities, and so forth, so which has stimulated, I think, more management interest. Sorry, there's my button. Sorry, my button is there we go. However, there remain many technical challenges, corporate data management challenges or normal issues with managing big data, but a lot of issues specific to transit related to ensuring data quality, factors affecting data quality, and the challenges in matching and cleaning data between scheduling systems and the AVL systems and the APC systems. And there are many organizational challenges continue to be internally. Transit is not really a data-driven or industry. It's an operations-driven industry, and it's slowly evolving, but that's taken some time. My computer is very slow. I did a report for the US DOT through ITS America, which discussed those challenges and came up with a typology of the various ways that automated data can be used. And there's systematic monitoring, dashboards, executive management level. Most people focus first on using the data for service and operations planning, on-time performance, running time analyses, operator performance. Increasingly strategic analyses, campaigns, major redesigns, part of the 5-year plans or comprehensive operating analysis. Tactical analysis, delays by intersection, locations for priority treatment, excessive stop dwell time, stop consolidation. And increasingly, with those systems that have sort of gotten their heads around the data, you can start doing exploratory or data mining in terms of safety analysis, accessibility, equity, and starting to see more for decision support for real-time operational control. So what's happened in parallel to that is that researchers have also become much more interested in data and its use. And so there was a small group of academics who've started with smart card data and then evolved into ITS data and other sources. And Amer's been involved in this group, and I have too. I'm one of the few non-academics involved. And so there's actually been a series of workshops. 2014 was the first one where it focused exclusively on smart card data. And then 2016, sort of thinking more about AVL, APC data, but also smart card data. And a lot of the focus in these first workshops were on how to use the data to develop origin destination matrices. Transit agencies are starting to become more interested in this topic, but this has been a prime interest of academics from the get-go. This was followed by a workshop in 2017 in Santiago, where increasingly started looking at operations-based applications on bus transit. In 2018, starting to think about passive data and its application. In 2019, new applications in travel behavior, and this led to Amer and I volunteering to co-organize the Transit Data 2020 symposium that was held this summer in Toronto. So this led to the symposium this summer. We, as everyone, were affected by the pandemic and decided to pivot to a virtual conference, and the team put it together in 10 weeks. And it was a big effort, but it worked out quite well. We had 250 participants. One of our efforts was really to try to get much heavier involvement by practitioners, transit agencies, and consultants, because all of the previous workshops had really been only academics. And we were very successful. We had 2/3 of the participants were practitioners. I had 100 speakers from 19 countries. I'll just run through what we did is we solicited submissions, and as I mentioned, people presented from 19 different countries around the world, and made them into what we called lightning presentations, 6-minute presentations. So you get a taste of everything throughout the program, the 3-day program. These were the topics of these lightning presentations. They were planning analyses, of course, origin destination enhancements, policy applications using automated data, operator performance, matching performance, transfer analyses, data quality, passive data, analytics for improving prediction accuracy, network analyses, and rail applications. So you can see people are really thinking very broadly about how you can use this plethora of data that is starting to appear from all the different systems. In addition to the sort of technical presentations, we also had a number of plenaries and panel discussions. So this included a conversation that I had with Nigel Wilson, who's part of the guru of this data. He was on my PhD committee and a good friend. And then data-driven analyses related to COVID-19. We tried to show the range of leadership in analytic labs, university labs around the world. but also wanted to focus a lot on sort of the organizational and institutional issues. So data management challenges, also discussion of data specifications, because there's a whole series of efforts underway to develop data specifications, new data sources, academic industry collaboration, and then looking to the future. And we also had a keynote by Dr. Kerry Watkins of Georgia Tech. So there's a wide range of information, and I wanted just to mention to everyone who wasn't able to attend that all the sessions were recorded, and all the presentations, both the lightning presentations, but we also allowed people to post longer presentations. They're all available for a small administrative fee at the transitdata2020.ca, and you can register there to obtain all this information. So the themes, I wanted to touch base on the themes. Now, starting with academics, of course, one of their key interests is methodological. So that's sort of where things started, and it continues. It's a key theme of all these efforts. But methodologies to clean the data, methodologies, new technologies to collect data, origin destination engines for inferring origin destination when you don't have tap off from smart cards, accuracy of new methodologies versus traditional methodologies, transit assignment, capacity versus scheduling, vehicle scheduling, and scheduling optimization. But as well, and this is probably more of interest to the participants in today's workshop, is the kinds of analyses one can do. And you can see from what I just mentioned before in the different sessions we had in the summer symposium, it covers a wide range. So started off with sort of looking at OD patterns, origin destination patterns, which actually reveals real demand and how people travel. Accessibility from a planning perspective, how many jobs can you reach from this location in 30 minutes by various transit systems. Travel behavior, how do people choose, or what bus stops do they choose to access, how far are they willing to walk, route choice, sources of delay. This allows, whether it's a delay at the stop or in intersections, it allows you to focus your priority treatments, either physical treatment or TSP. On-time performance, problems with overloads and pass-ups, optimization in general. But then as the symposium evolved, it sort of looked at new horizons. So behavior and disruptions. What happens when there's a disruption in terms of where does crowding occur, or where does passenger movement take place? How do you, what decisions should you take to inform the passengers when disruptions occur? Service quality in terms of measuring excess wait time. Predictive analysis, passenger loads, trying to use past data to predict future loads. Real-time, this is sort of, we're starting into real-time operational control dashboards that measure gaps in bunching and give strategies to dispatchers. Opening up ITS data, a few, not very many so far, but real-time passenger information, RTPI, is pretty much used, available everywhere. That's what's used by all the third-party apps. But actually opening up real ITS data is starting to occur in a few systems. And then the use of passive data, cell phone traces and Wi-Fi traces and so forth. And the newest horizons, well, it's linking performance to experience because we're now getting sources of data that are objective performance as measured by the AVL systems, but also we can start getting better understanding of behavior and the experience as measured through social analytics and things of those sort. So this gets into emotional behavioral analytics. And then in parallel to all this is deep learning in AI, which is given the tools to process massive amounts of data. And then we've seen this year, COVID response, visualization of the situations, real-time crowding monitoring, and that's really the topic of the next session. But we wanted to look beyond, as I mentioned, into organizational type issues. So dashboards, operations, planning, but also accessibility from an equity perspective, quality control, data management, and collaboration between academics and practitioners. this is linking performance to customer experience, I think is particularly important. I always show this chart from a European standard on quality of service in public transportation that's, I think, 20 years old now. But you can sort of see on the right-hand side what we normally focus on, which is the measurement of performance. But performance isn't objectively perceived by passengers. And so we need a better understanding of measurement satisfaction, which actually links planning and market research, marketing, so you get a full picture of service development. So that gives you a quick recap of the evolution of how we got here and the themes that have been explored through the different symposia and as well in the one this summer. If anybody is interested in the report I did for the about challenges, we'll talk about that later this afternoon, but that's available. You just give me just send me an email. And also, as I mentioned, the symposium presentations and recordings are available by registering at the transitdata2020.ca website. Thank you.
Thank you so much, Brendan. It was a very nice overview of the Transit Data Symposium, as well as the history of those symposia. Ours was the 6th, as Brendan mentioned, and there's a growing community of both academics and practitioners who are very active, getting more and more active in this space. And it's actually very encouraging to see a lot of enthusiasm and a lot of creativity really of the work that's being done around the world in this, in utilizing the transit data in a wide range of applications in both planning and management. So we have a few more minutes, maybe 9 more minutes. Anyone would like to make a comment or ask questions either to me or Brendan, please do so.
Hey, Emmer. We did have one question that came into me, which was curious, is from Vibert. I talk a little bit more about ridership forecasting, if you can expand a little bit on. I think you mentioned some ridership forecasting in your presentation.
Yeah. Well, U of T has a very long-standing history in this area, led by my colleague, Professor Eric Miller, who's been, I think he's very well known worldwide and in our region here. In travel behavioral modeling and forecasting. So we've been working on a wide range of models, both the multimodal as well as transit specific, like direct demand models. So the ones I was referring to can be thought of or classified as direct demand models, ridership models, either at the city level or at the route level. So yeah, we've been, one recent study we did for QTA, in which we looked at the ridership trends over a 15-year period from 2001 to until 2016 for 103 transit agencies in Canada. So it was a panel data set in which we looked at both short-term elasticity and long-term elasticity of demand with respect to fares, with respect to gas prices, and so on. So yeah, this is quite an active area of research here from a behavioral perspective, as well as ridership forecasting, specifically for public transit. I should also mention that, yeah, my colleague, also Professor Kanker Noor Al-Habib, is also a very active participant in this area. His research, the focus of his research program is on travel behavioral modeling, part of which is on transit ridership forecasting and analysis.
I think a small follow-up to that was specifically about forecasting in COVID, which of course is a much larger conversation, how to sort of adapt your predictions. Yeah, if you'd like to go ahead, go for it.
Yeah, I saw a question that was aimed at me about small transit systems that don't have often don't have APCs. it's actually a broader issue than that, because part of these efforts are aimed at this. Having monitored the industry for a long time, it's one of its characteristics is the fact that there is a very wide gap between the leaders that use sophisticated tools and have recognized the importance of data and drive their decisions through data, but which are very few in number, and a large number of agencies that have tools, but for various reasons, various challenges, aren't able or don't use them, all the way down to small agencies that sometimes have tools, many times don't have staff. There's a long lag between disseminating, deploying tools and best practices in the industry, and it's always been the situation. It's one of the challenges in trying to develop a collaboration between research community and the industry, because of course, generally the academics wish to work with the most sophisticated ones because they were using the most sophisticated tools and techniques. I think small agencies are increasingly being equipped with AVL because the price of some of these systems are coming down. The vendors have a long way to go in terms of making their systems, the data reports that they provide, more robust. It's a slow process, but I think I'm encouraged to see how many people within the industry, including in this workshop, come from small to medium-sized agencies, and hopefully this stimulates more discussion of what is needed to help not only the best agencies in terms of the most sophisticated agencies, but the industry as a whole. And that's one of my objectives in participating in TAL.
I have a follow-up question that came directly to me, which was what sort of do you see as the greatest gap between academic literature and, I guess, academics and practice? I imagine that's for both of you.
Yeah.
The gap between literature and
like academic literature and research, and what's being done in practice. Where's the biggest gap? I realize there's probably many, but
you want to have a crack at this, Brandon? you've been grappling with this question for so long.
I did not pull out my 4-tier picture, which I've used many times, but I'll describe it and it sort of was implicit in my previous response. I see the industry in 4 tiers. The top tier is the state-of-the-art, cutting-edge ones that tend to work with academics, the Transport for Londons, the Singapores, the Zurichs of the world. Very few in North America. In some agencies, there are some examples. That's a top tier. The bottom tier is the agencies that are there for purely as a social service, because there's no way they can compete with the automobile. Small cities where it takes 15 minutes to drive, and the hourly headways are, hourly headways. So who would wait for a bus? The second tier from the top is best practices. And there's a growing number of those, and this is what we're aiming for. And then the bulk, though, is sort of standard operating procedures. And my objective has always been, how do you get, if you really want to make the industry better, how do you move more people from the standard operating procedures into at least the best practice level? In terms of the academics, this is part of my reason I was a little frustrated with the symposium over the years, is that academics, their career path is guided by their ability to publish in academic journals that are totally inaccessible to practitioners, and they rarely get brownie points for doing applied research. So that's why I commend Amr and his students, because they're trying to find a path. And some of these other research institutions we talked about, MIT and TU Delft, have been trying to do the same thing of finding a middle ground where there's academic benefits, but there are real benefits to practitioners and to the industry as well. It's a real problem. And this is why I didn't mention, but I'm very involved in TRB, Transportation Research Board, because it's probably the only forum that really normally brings together academics and practitioners and consultants. And I've been involved. I was chair of the Transit Planning Committee for many years, and I'm now chair of the Public Transportation Group. it's one area. So if you look at the TRR, but even there, you have to pay to get the articles. So there's no easy answer to this. I don't know, Amer, if you have any additional.
Yeah. Just a follow up. I think Brendan mentioned TRB. There was a session actually a number of years ago at the TRB looking at the gap or the divide between the academic world and the professional world. But I think me and others see that this gap is narrowing with time. So I think in 20, 30 years ago, academic research was highly theoretical, and as Brendan mentioned, was really published in journals that are very inaccessible to the industry. But we see now this gap really is being bridged slowly but surely. More and more academics are working with the industry and vice versa. So we're hoping to really continue this trend. And I think this will be a topic and a question that will be addressed more today in different sessions of this workshop. I recognize we've come to the top of the hour, so that really brings us to the end of this opening session.
Just one quick question.
Sure.
Comment. That's part of the reason we've kept all the recordings and proceedings still available. Most workshops, academic workshops, the proceedings are never published because they're only published in those academic journals. So this is part of the process. We're trying to make things more accessible as we work through this.
Yeah, thanks. Very good point. And also, speaking of which, this workshop, also the presentations will be shared with the participants. I think there was one question about that in the chat box. So you'll receive a copy of the presentations here. Okay, so thank you so much. We'll have a 15-minute break, and please join us at the next session, which will be a very exciting session featuring a few presentations on efforts by transit agencies in response to the pandemic. Thank you.
Thank you. Yep. And just as a reminder, you can use the same link to join the next session. I'll start it up again in about 15 minutes or so. So see you soon.
See you.